After more than a decade on Mars, NASA's Curiosity rover has just made one of its most exciting discoveries yet. Now it's helped solve a major mystery about the red planet's ancient climate. This new discovery has shocked scientists, and all because of one very special rock. It may not look like much, but it holds secrets about what the atmosphere was like when Mars could have supported life. It might even help answer the question of whether we are alone in the universe. Here's what happened. NASA's Curiosity rover has been exploring the surface of Mars since 2011. It has explored mysterious methane spikes, sent us incredible close-up views of the Martian sand dunes, and even captured evidence of an ancient lake. His mission was planned to last just 2 years, but it's still going strong and has far exceeded everyone's expectations. And now it's made a discovery that could change everything we know about Mars. Curiosity is currently climbing up a giant hill inside Gale Crater, a massive bowl-shaped depression that's 96 miles wide and 160 feet deep. It formed billions of years ago after a large object slammed into the planet, and according to scientists, it may have once been home to a lake. The crater's central peak, called Mount Sharp, is also known as Elis Mons, and it's here that Curiosity has been steadily making its way upwards over the past decade. The reason the mission chose this location is because Mount Sharp contains layers of sedimentary rocks that formed over billions of years. By climbing up it, the rover is essentially traveling through time and can see the entire geological history of the planet at once. Scientists hoped this would allow them to piece together how Mars went from being a warm and welcoming world to the frozen desert we know today. They also wanted to find out why Mars lost its atmosphere and how that affected its ability to support life. The problem was, they didn't have a good understanding of the early carbon cycle on Mars. To understand their discovery, we need to talk about carbon, because it's essential to life as we know it. Carbon is the backbone of all organic molecules and is present in all living things. On Earth, it constantly cycles between the atmosphere, oceans, land, and living things. Plants absorb carbon dioxide from the air and convert it into organic matter. When they die, much of that carbon is released back into the atmosphere. The same goes for when we humans breathe. This constant cycling keeps carbon moving and available for life to use. But there are also larger processes at play. Over millions of years, microscopic sea creatures have absorbed carbon dioxide from the atmosphere and sunk it into rocks and sediments on the ocean floor. This process is called carbon sequestration, and it's one of the reasons Earth has turned into a greenhouse. However, without these processes, Earth would be a very different place. As we know, there would be no fossil fuels, which means we wouldn't have been able to power the Industrial Revolution or develop modern plastics. There would also be a lot fewer caves, because many are formed by the weathering of carbonate rocks. So how did this work on Mars? Well, it turns out the Gale Crater rocks hold the answer. So far, Curiosity has found 3 types of minerals that form in the presence of carbon: sulfates, perchlorates, and carbonates. Sulfates were created when carbon dioxide-rich water evaporated. Perchlorates formed in water that was salty and the newest discovery, carbonates, formed in water that was slightly acidic, salty, and carbon dioxide. Scientists know that because of the chemistry of their formation. Each of these minerals should have formed at a certain temperature, and the presence of certain minerals in a certain area gives scientists clues about the climate at the time. For example, scientists already knew that sulfates required temperatures above 32 degrees Fahrenheit. They also knew that perchlorates required higher temperatures, 41 degrees Fahrenheit or more. The presence of both of these minerals in the same location told them that at some point, the temperature must have risen above freezing. But the discovery of carbonates was a complete shock. That's because their formation requires temperatures between -4 and 86 degrees Fahrenheit, and the fact that they re-found at low elevations suggested that they formed relatively recently in Martian history. This means that at one point Mars had a carbon-rich atmosphere that could support liquid water and even possibly life. The discovery of these carbonates also confirms long-standing climate models. Basically, it supports the idea that Mars once had a thick atmosphere with a high concentration of carbon dioxide. Here's how it worked. Volcanic activity released gases from Mars's interior, including carbon dioxide, which eventually filled the atmosphere. Once the atmosphere reached a critical threshold, it started to trap heat and raise the planet's average temperature. Liquid water could exist, and with it, life could thrive. But unlike Earth, Mars didn't have any plate so as the volcanic activity decreased, the carbon in the atmosphere never got recycled back into rocks and soil. Instead, it started to precipitate out of the sky in the form of rain, and over time, it filled the lowlands and created lakes and oceans. Eventually, however, all the carbon sunk to the surface and it became locked away in rocks. With no way for it to get back into the atmosphere, Mars began to cool, and the liquid water froze. The planet we know today formed, and with it, any chance of life disappeared. This is the first time anyone has found direct evidence that Mars had a carbon cycle like Earth's, and it's a huge step forward for our understanding of the planet. But there are still many questions. How long was Mars warm? Did any carbon ever make it back into the atmosphere? And most importantly, was life ever able to evolve? Unfortunately, scientists don't have all the answers yet, but they hope to soon. Curiosity's mission was extended through 2023, and the rover will continue to climb up Mount Sharp. In the meantime, scientists are planning a sample return mission to bring Martian rocks back to Earth for the first time. This will allow researchers to study real pieces of the red planet in their own labs, which could lead to even more discoveries. What's clear is that Mars was once very different from the cold, barren world we see today. And the discovery of these ancient carbonates is just the beginning. Other rovers on Mars are also making amazing discoveries. Perseverance is searching for signs of ancient life around Gale Crater, while the New Dragon mission is exploring the surface of Mars and looking for signs of water. As we learn more about Mars, we're slowly piecing together the puzzle of its ancient climate. If we can figure out what happened to the red planet, it could help us understand what led to the extinction of dinosaurs on Earth. It could also help us predict what's in store for our own planet. After all, we're facing a climate crisis, and every bit of knowledge is crucial. And who knows, we may even find evidence of life. On Mars, NASA's missions to Mars have been revealing more about the planet than we ever imagined. And the discovery of the carbonates in Gale Crater is just the latest example. We've come a long way since the first crewed missions of the 1960s, and today's spacecraft are more advanced than ever before. We're now at a point where we're discovering new things about Mars every day, and it won't be long before we can explore the red planet ourselves. One day, we may even find evidence of life on Mars, either in the form of fossils or even living creatures. If we do, it would be one of the most important discoveries in history. It would mean that we're not alone in the universe. It would also mean that there are other planets out there that could support life. It would open up a whole new world of possibilities, and we could finally start to explore the galaxy. Of course, there's no guarantee that we'll find anything, but the search itself is exciting. Every new discovery brings us closer to understanding the red planet and its history, and who knows what we might find next. If you liked this video, be sure to check out my others for more fascinating insights into the world around us. And don't forget to subscribe so you never miss an upload. Thanks for watching.